Hello class, I'd like to introduce you to laboratory activity 3 about the impacts of global climate change, because we're going to be looking at now how humans use natural resources, and one of the biggest parts of using our natural resources is that we produce greenhouse gases. And instead of lecturing it to you, I want you to do an interactive activity with this. Now, you cannot use this activity on Apple products from what I understand, particularly an iPad, and it may not work on your phone. So you're going to have to do this on some type of PC, and hopefully your Chromebook will work too. But this is a very interesting and very accurate simulation of global climate change. So when you go to our D2L site for the class, you'll see two important features. One is going to be the simulation, which you'll just click on the hyperlink for that. And there's also, I don't know if that executional file will still work, because that's an older variation of the activity. So if you still have Java on your computers, that will work, but this one should always work above. Plus, there's your laboratory worksheet, and answer all the questions, and I'll show you where the questions are. And then what's also important to do is to review this video, because this is looking at sustainability and the impacts of global climate change. But you'll need that as sort of background to understand, again, where global climate change affects our ability to become a sustainable world. So again, your sim's going to be here. That's going to be the link that takes you directly to the website. I did store an executional file that's not going to work on all computers, but it may run a little faster for you if you have slow internet. And then again, your laboratory worksheet, you should keep open up while you go through the sim, and just directly write into it and put it into the Dropbox below. So when you click on the hyperlink to go to the activity, you'll see a window that looks like this. And this is where your activity is going to be. You just click on the start sign, and don't worry about any of these other things on it. So just click on here, and that should immediately bring you to the active site where you'll be doing your sim. Again, after you pull up your sim, please pull up the and have ready your worksheet, which will be a Word doc. And please, when you submit this, some of you have been converting to PDF, and particularly if you're on a non-Windows system, sometimes the PDFs come out messed up or reformatted. So it's best to just submit this as a Word doc form after you input your answers. But please read the instructions. The hyperlink for the lab is there, but don't worry about that. But please read the instructions and follow the order that's in here and answer all of the questions. Now, how much information do you put for this lab? What I'm most interested in is seeing the data plus a very short one-sentence explanation of why you put that answer. So I'm mostly looking at you getting an estimate of the amount of what are called photons or particles that are contributing to global climate change. So when the activity loads up, it's probably going to go to a different window. And here are going to be your window options for this activity. Your first activity is going to be called photon absorption. Okay, and it's probably not going to open up to that window when you open this up, but just click on photon absorption, and that will bring you to this window pane. Your next activity is going to be glass layers. And then your third activity to follow this up will be greenhouse effect. So this is a tutorial plus an interactive. So you can see here, there's going to be different options that you can play around with. So these buttons are going to be very important, and these are going to be important too. But just to begin, we're going to look at what is a photon. That means what is a unit of light. And this thing here is a lamp that you can control with this slider. And it does take a lot of clicking on that slider to get it to work. It's a real pain. But that shoots the equivalent of sunlight, okay, at a molecule, and that's a molecule, and that one happens to be methane, which is right here. And don't worry about its chemical formula, but that's just methane. And the instructions, the names of the molecules will be in the lab write-up. So this is a methane molecule, and that's just it kind of floating around. And we're going to see what happens. You can change molecules, for example, CO2, and I'll ask you to do that in the lab manual, or H2O, and that's nitrogen, which is abundant in your atmosphere, and there's oxygen. And there's another option too where you can manually build an atmosphere based on instructions in the lab manual, or you can just mess around. So first, let's look at what your photon activity would be when you first started. So in this slide, what I did was I uh, clicked on carbon dioxide because that's the major greenhouse gas that we deal with. It's not the worst of the greenhouse gases, but it's the most abundant as far as its impacts on our environment. So we can do that. So here's your molecule, and I just put one in there to show the impact of one CO2. That's all we're doing, and that's a photon of light. That means sunlight. And you see, and pay attention to what happens to that molecule when a photon hits it, because you're going to be asked. And what you're going to see is this molecule is going to somehow interfere with the photon. And anytime you're interfering with a molecule, that can produce heat, depending on, you're going to see how that molecule is affected. So just be aware of that as you're watching this. And you're going to do this for the different molecules up here. Place them in there. Of course, reset. There's a reset button down here to remove that. Always go to your reset button if you screw up, I should say. And just try different photons. And again, you can adjust the photon level to look at in sunlight intensity, because this actually controls light intensity or sunlight intensity, because this is going to vary. Like when I was in Fairbanks, Alaska in the winter, there wasn't much sunlight intensity, so we didn't have many photons of sunlight hitting the earth. But when you're on the equator, when I was doing work on the equator, in a cloudless environment, direct sunlight, man, that was a lot of sun. So think about that as you're controlling this little thing here, is that sunlight does vary from region to region. Now in this feature, what I did was I now got out of this window and clicked build your own atmosphere. And I just added what I wanted to add. So I added what we call 2 parts of methane. And methane is a pollution that usually comes naturally from swamps and other areas. But also it's a major pollutant that we produce with the production of petrol and the use of petrol. And there's CO2. Again, CO2 is produced naturally, but most of it is produced through anthropogenic human activities like driving or, combustion, burning things. N2 is a natural component of the atmosphere. It makes up about 70% of your atmosphere, but we could also deplete it by harming soils, or we could increase it by also messing up soils. And then there's your oxygen right there, which is going to be pretty consistent unless we remove a lot of vegetation or damage our oceans. So all of these are in here, and I can shoot them with sunlight and look at what happens again and just compare them as far as what they do when sunlight hits them. And a big hint about this is look at what happens when sunlight hits them is they vibrate. That's what photons do. And when they vibrate, that produces heat. So think about this as you're looking at it and answering questions in your laboratory sheet. So our next activity is going to be glass layers. And basically what we mean is that certain types of pollutants and water in the atmosphere and even clouds act like a layer of glass. Now think about that. If you're sitting in the sun directly outside, you heat up a little, but the air around you gets dispersed away. Now, if you're sitting under a glass dome, sunlight can come in and penetrate the glass if it's the right type of glass. And the problem is that things heat up in there, but it doesn't escape like when you're sitting outside because the air is trapped and things heat up. And we call that greenhouse effect. So in this activity, which is a very simple activity, you're just going to look at sunlight and photons. And you could push this button too and say view all photons, but it's hard to count. It's just for representation. These are what you want to kind of try to count and look at as you change the number of layers of glass. So right here, you have no layers of glass and just basically look at the sunlight coming in, which is those, and the amount of heat, or those red particles, which are what we call photons and infrared light coming out. So just pay attention to the amount or the ratio of yellow to red. So this is basically no glass, and that means this is a pure atmosphere. So what I did in this slide is I changed the number of glass layers to 2, which would be a pretty dirty atmosphere. So notice your glass layers here, and again, this could be anything. This could be a pollutant that we call a greenhouse gas. It could be cloud cover. It could be humidity, in the air. So now you will notice that for the amount of photons of sunlight coming down, there's an increase in the red. And notice the thermometer too, obviously. You can tell the temperature change. So just mess around with this. And this controls the speed of the particles. Don't worry about that so much. But what you're more concerned about is, basically what happens as we add layers to the atmosphere and what's the impact of global climate change. Because each glass layer, will increase the heating with the amount of sunlight coming down. So now we're going to go to your actual activity called greenhouse effect. And you have to do these two first in order to get a background on this. So here again is your window, and there's going to be two settings you're going to mess around with. This is called a preset, in which it gives you different types of atmosphere. Today, 1750s, literally ancient humans about 20-something thousand years ago, the Ice Age. And this tells you the amount of materials in the atmosphere. So please pay attention to those numbers right there. These are part of your presets. So the preset for today is going to have a certain level of CO2, which is pretty close to what we call the critical point, because we don't want above 400 ppm, what's called 0.04, percent of CO2 in the atmosphere. Because that's, once we get above that point, we're going to see that there's an amplification of the greenhouse effect, which is pretty bad for the consequences it can have on Earth. This is going to be another activity in which you could actually adjust on yourself the levels of greenhouse gas just to look at variables. And down here is going to be some other options. So we can look at cloud cover with this option too if we want to, and also change Fahrenheit to Celsius depending on what you want to measure. So in this screen, I'm still in today in my preset, and what I did was I added 3 clouds, some cloud cover, and cloud cover could be a result of humidification. It could be a result of particles in the atmosphere. Pollutants actually could precipitate cloud formation. So cloud cover is going to be very important in this too as you do those settings. So now in this slide, you can see we clicked on 1750, and it shows basically an agricultural society, no dense population areas. I mean, there was some, but not, United States really. Okay, not as dense as they are today. I mean, we had, cities developing, and Europe was pretty dense at that time, but still. So we can see here, at least in this, is again the amount of sunlight particles coming down and the amount of heat being produced by the Earth. And you're going to compare this preset to today's and to the Ice Age and just hypothesize on the whole idea of why is there more or less heat being developed per sunlight at these different times. And just again, pay attention to the numbers in the preset, and also pay attention to the number of heat particles that are being produced over a certain period of time. And again, you could add clouds to this, do whatever you want. But the major thing is to not run too many variables at one time and just look at it very simply of what is producing all that heat. Okay. Now, in this activity, what I did was I clicked on the slider, and immediately this window, kind of goes dead. And don't worry about the cloud cover at this point. You don't care. But what you can do now is adjust this to manually adjust the greenhouse gases. And don't worry about the ratio. What I'm mostly looking at is, CO2, which is the most abundant one. I mean, I wish we could do different sliders for methane separately, but that gets a little crazy. And in research, we actually use this. This is a real sim we would use in research to do that. So when you adjust this slider, you can see I set it for almost no greenhouse gas. And it's very clear, and I kind of like the satellite or International Space Station up there. But anyway, so this is to be 0. So in this slide, what I did was I moved the slider over to here to almost a maximum, and you can see how hazy the sky looks. Now the problem is when this is the haziness, is not really, greenhouse gases don't make the atmosphere hazy. This is just showing you that this greenhouse gas is there, there's particles there. And then notice again, compared to the clear sky, in a way, the amount of heat being generated. Now again, this heat is being produced when photons hit the atmosphere, they shake up the particles, they also hit the Earth, and it forms heat, particularly in this region that Usually, if there's no greenhouse gases blanketing it, this heat escapes, okay, into the atmosphere and cools the Earth. Whereas if it's trapped or caught or it's vibrating greenhouse gas molecules, then you have a problem because that heat starts building up down here. So good luck with the lab. It is fun. It is a great sim. And guys, this is your experience at actually using simulations without having to calculate it mathematically or get the data from a spreadsheet and import it. So this is what we do in research. We use these sliding scale, experiments, what we call virtual experiments, to understand how global climate change affects us and how we can fix it or remediate it. So have fun. And again, if you have any trouble with the lab, just send me an email.